Hey, and welcome to my channel once again. Today I'm going to be sharing a little bit of something I'm working on using YOLOV8 locally on my workstation to train a model on some of the data I've been collecting from flying the drone over San Francisco and detecting piles of garbage. I decided that I wanted to be able to train a model with full resolution photos. It's a bit arbitrary of a decision, and I'll tell you why. And there is a way to, there are two ways to think about this. One is I could slice up the images and on each image, and then run my machine vision model, train it on a smaller training image. Typically that's 640 by 640 pixels. But I'm capturing a very large image. I'm capturing a 4K image. Um, Actually, I think it's a bit bigger than that. Let me check exactly. It's a big image. Um, it is. Okay, so the images are 5,280 pixels by 3,956. So that's bigger than 4K. It's slightly bigger than 4K. I think it's like 4.5K or something like that, or like 5K. And most machine vision models cap out. Well, actually, the models themselves, a lot of them do cap out like around, I think, a thousand pixels, either width or height maximum. But some of the some of the models like YOLO and RetinaNet allow you to train it on as big of an image as you want. The only limitation when you're training on those models is memory in your GPU. And if you're in the cloud, you can use something like an H100 or an A100. And I think those have like either 80 gigabytes or more. But if you're training on your local machine, you may not have that much. And I certainly don't have that much on a single GPU. But I do have some RTX 6000 ADAs in my machine, two of them. And I'm able to, they each have 48 gigabytes. So I can train on these vision models. There are ways to parallelize it across GPUs. I haven't done that yet. But what I am able to do is train it on a single GPU or batch it across multiple GPUs. And with a maximum memory usage of 48 gigabytes for the model, I can train my model on 2K for sure with a batch size of 16. So right now I'm going to try and train it with a image size of 4K and a batch size of 8. And so that's what I'm sharing here today. The other way to do this would be just to either downscale or downsample the images to like 640 by 640, or to chop the images up into smaller images and then remap the bounding boxes. So that's another way to do it. I wanted to see what would happen if I trained my model on as high resolution as image as I could handle and see if the performance in the real world is better. So that's what I'm working on. All right, so I'm going to jump over and just share my notebook. So there's a couple steps to this. The first is I need to convert my data set into Cocoa, which is the format that YOLO accepts. And I wrote a little bit of code that pulls down my manifest file, or that loads up my Amazon Recognition or Amazon SageMaker manifest file, which is a proprietary format that Amazon uses for their machine learning models. And I'm using that proprietary format because I'm using their managed machine vision packages. The one I'm using right now is called Recognition, and it's just more convenient for me to do everything in Recognition because I can save to my manifest everything within S3. I can kick off trainings automatically, and it's pretty much pretty easy to manage, but I may not be getting the best performance out of my model. So here's what so here's me pulling down, opening up that manifest file, and then going through and taking all of the lines, the JSON lines in that file. It's a JSON line format, which means that each line is a JSON object, and then appending that to a data array. And then I go through that data array and I download all the images, because all the images are stored in S3. So I need them locally if I'm going to train. And then I also reformat the manifest format into a Cocoa format. And so I have to do a couple other things before that, changing some of the naming conventions they have in the manifest file, like the job name. I need to change it to BB, and then I need to change the manifest item to BB metadata. That just stands for bounding box. That's just kind of a little housekeeping item that I need to do to make things line up. I'm not going to explain that because it's pretty boring. And then I adjust the image reference to be a local reference versus an S3 reference. So I'm downloading the images. So I just go ahead and say that image is going to be in a directory called data. Okay. And so I use that map function to map over the whole data set. And then I go through and I download, and then I write each item to its own file. First I've got this adjusted manifest file, which is in the same format. I've just adjusted the location of the images and adjusted that one BB bounding box item. And then I'm writing that to a new manifest file. And then I'm using something called optical, which has a SageMaker converter. It's just a library I found on GitHub, and it works. I'm using that to convert from SageMaker to Cocoa format. And Cocoa is what, once again, YOLO uses for the training data. It's a format for the training data. So that tells it where how big, the size and location of the bounding boxes, as well as the label, and as well as the image location that it needs to load for that specific data point. So then I do a scatter plot just to see how big where the size of the bounding boxes distribution looks like, because I thought I was having some problems with having too small of bounding boxes, but I don't think that is a problem anymore. And then I just save that into a new format. So now that I have that in a new Cocoa format, I can go over and I can load up my Cocoa notebook. And in my my YOLO notebook, which is YOLOV8, I can load up a new YOLOV8 model with this YAML file that tells it this is the architecture of this convolutional neural network. Here you can see it has 2 convolutional layers, then a C2F, whatever that is, another convolution, a C2F, a convolution, a C2F. I think that's that's a reducer that reduces it down. And then, anyways, that has the architecture. So I'm almost done here with this stream. I'm just going to make this really quick because I got to go. But then I set some parameters on this, and I make sure PyTorch is loading and is good. Then I can basically train it, and I set some parameters. I'm going to set the image size to 4096, the batch size to 8, and I'm going to tell it to go on device 1 because I'm only doing single device training right now. That's the GPU one. And I give it the dataset information, which I've loaded up, which just points to where I saved the dataset in Cocoa format. And then I hit enter. Now it's going to go through, load up the model. I'm using WNB to monitor this model. And so I can go over there and monitor it in a second. But it's going to go ahead and start training here in a second. Let's see. I haven't tried it with 4000 with a 4K image yet, so we're going to see if it tries to run out of memory.
Wait, can you pause?
I will. I'm just 5 minutes. 5 minutes. Okay. So let me just load up a new window here, and we're going to open up NVIDIA SMI, and we'll be able to see like how much memory we're using up. And so you can see here that we are using 42 gigabytes of the 49-ish, or the 48 gigabytes, somewhere around 42 gigabytes of the 48 gigabytes that are available. So it's actually seems to be within the GPU right now. So this is a batch of 6 with a 4K image. Now, if I can figure out how to parallelize this across 2 GPUs, it'll be twice as fast because I can do bigger batches. I can do a batch of 16 and do 8 on each GPU. So that's how that's working. So that seems to be working. All right, so we're using 42 gigabytes of video memory to train this model on a 4K image. So that's working. Pretty cool. That's all I really wanted to show you on my stream today. Figured I'd give you an update on one of the things I'm working on. I do have other news. Like this week, I'm presenting at a illegal dumping conference in Oakland, and I've been preparing for that. So one of the things I want to do tomorrow is practice or show off some of my presentation to you all so you can get a sneak peek. Anyways, that's it for today. I got to go. But anyways, thanks for tuning in, and I'll see you next time.